Good afternoon. I think you can hear me. Uh, I'm Dr. Naomi, your physics lecturer. I think you can see my screen. Welcome to the BEd program in physics course. I'm Dr. Naomi, your physics lecturer. I'm going to start the session now. Uh, First, see about the introduction to physics, why we are learning about the physics and what are the importance of the physics, right? Then, what is the physics? Then, physics is the study of matter, energy, and the interaction between them, right? Then, physics aims to understand the natural phenomena and develop laws and theories, apply mathematics to physical systems. These are the importance about the physics. Uh, Physics explain the phenomena from very small scales. Then we can explain using the physics with about atoms, electrons, and things, right? And everyday scales, then motions and forces. In large scales also, physics is important. We can apply physics phenomena for the planets, stars, and universe also, right? Then there are some main branches in physics we have to cover. Uh, when we are learning in physics, then we have to cover these branches. These are the main branches: mechanics and thermodynamics and electromagnetism, optics, waves and acoustics, modern physics. The main branches are here, right? Then, first, as we learn in the physics, as the teacher, then we have sometimes we have to teach our students. The mainly BEd program students has to have to teach the uh, students. Then we have to know what is the scientific methods, right? Then physics follows a systematic method. Then observations, hypothesis, experiment, data collections, analysis, and conclusion. These are the systematic method. The physical experiment or scientific methods. First observation, then after that we can build the hypothesis, and then we can build the experiment to improve the hypothesis, and to prove the hypothesis we can design the experiment. Then according to this experiment we can collect the data, and after that we can analyze the data, and based on this data and analysis we can take our conclusion. We can go to our conclusion. This is systematic method. We call as a scientific method. In physics is based on measurements. Physical quantities include length, mass, time, temperature, force. Measurement must include in numerical value and unit. Uh, in physics, the measurement in the physics, the numerical value and units is important. Then other thing is scientific notation. When we Right. Then what is the scientific notation? In scientific notation, any number is written as number between 1 and 10 times an integer power of 10. The scientific notation is a way to write very large or very small numbers in the simple form using powers of 10. This is important things that we cannot, sometimes we have to write the numbers with so many digits, right? Then so we can convert this into the scientific notation, right? Then as an example, you can see in my screen the radius of Earth approximately some 6380, and you can see some zeros here, meter at the equator. So then we can write this in the scientific notation, right? Scientific notation is a way to write very large or very small numbers in the simple form using powers of 10. Then here you can see we write this is into how many tens power here. Then we can count this from the final 0 to 6.38. 1, 2, 3, 4, 5, 6. Right? Then 10 power of 10 is 6 here. Then we can written 6.38 into 10 6 power 10 6 in meter. The importance of the scientific notation, right? For the large numbers, then you can see here one large number, then decimal place is uh, move to the left, right? Then left hand side we can move to the decimal place, and what happened the power is the positive power, right? Then we can count how many places you move the decimal. Then in decimal places in this at the end of this number, so then we can move our decimal to the left. Then 1, 2, 3, 4, 5, 6 like this. Then we can write as 10, 6 power 6 with the positive power. Another one is that we can use scientific notation to write the very small numbers, right? As an example, you can see the radius of hydrogen atom expressed so many zeros and 5, 3. 0 point, and how many zeros you can see? 1, 2, 3, 5, 6, 7, 8, 9, 10, and 11 zeros here, and 5, 3 meter, right? 10 zeros and 5 3 meters. After the decimal place, we can see 10 zeros, right? Then in the expressions, and when we are doing some experiment or parting, it is very difficult to write this number. So we have to write this number as in scientific notation. Right? In the four small numbers, this is the very small number, radius of the hydrogen atom. In what happened the decimal place? Decimal place, move decimal place to right hand side. We have to move decimal place to right hand side. Then you can see how many decimals: 1, 2, 3, 5, 6, 7, 8, 9, 10, 11 point something. We can see 5.3, and also we can be written 5.3 into 10 minus 11 meter. What thing is negative sign, negative power is need to express the solution because the move decimal places is moved to the right hand side, right? Then in the first one, decimal place is moved to the left hand side. Power is negative, positive value. And the second number, it is very small number. The decimal place moved to the right hand side and negative numbers, right? Then it is very important in the scientific experiment or scientific calculation. Mostly in physics, scientific notation is important, right? Then I think you got the idea how we write the very large numbers or very small numbers using scientific notation, right? And also we can convert back to the normal number. In the positive power, we can move to the decimal place in right hand side. And also negative power, we can move to the decimal place to the left hand side. Scientific notation eliminates the need to write zeros to locate the decimal point correctly. And it is very important. We are uh, starting point, then we have to clear about the scientific notation. Okay. Another thing is, after studying the scientific notation, I mentioned about the before, about the measurements must include numerical value and the unit. The unit is important part, important role in physics, right? We will see. Then based on the SI units, standard units, we know we can write length. We measure length by meter and mass by kilogram, time, seconds, temperature, Kelvin, current, ampere. These are the SI units, right? In the measurements, these are the SI units. The metric system, then standard units you can see in this slide. Then a metric system of units, the systematic international units, then abbreviated by SI, is based on the powers of 10. The metric system, the meter for length, the kilogram for mass, the seconds for time, and for mole based units, right? Then you can see in table 1.1 in here, what are the quantity and unit name and symbol. You can see these are the SI units we used in physics or science, right? Then derived units are constructed for combination of the base unit. Then we can take the combination of the units, basic units. From the basic units, we can take combination of the units, right? Then in the example, then SI unit of force. Then you will study about the force for the next questions. In the force, we measured by the Newton, but we can give combination of units for the uh, force, right? kg, kilogram, meter, ms minus 2, because in the Newton's law, uh, force is equal to mass into acceleration. I think you have the basic knowledge, so we can derive uh, force, units for the force as kg ms minus 2, right? This combination of unit is given a specific name as the Newton, capital N, in honor of Isaac Newton. The Newton is derived unit because it is composed of a combination of base units. So this is the derived units. We can derive the units are constructions from combination of the basic unit. Then we know kg, kilogram is basic unit for the SI unit for the mass, and meter, SI unit for the length, and second, SI unit for the time. Then this is the Newton force. kg ms minus 2 is the combination of units for the force. Then you can see more examples here. Then velocity. Velocity means displacement over time. The unit is ms minus 1, right? Then acceleration also change of rate of velocity, the simple form. Then we can write ms minus 2. We can derive units using the basic unit, right? And energy also kg m square to s minus 2, right? Right. Other part is then important things in the basic idea. I'm giving here basic idea. After that, we can move to our lessons. Then these are the important things you have to follow up at the beginning of the sessions, right? Then other thing is graphs, right? This is very important in doing the experiment part. Then graphs are important. When we do experiments in physics, we change one quantity, right? Then we can change one quantity and see what happens to another, right? Here we introduce two variables. Then we change one quantity. We call this as the independent variable, right? And after that, we see what happened to other quantity, right? Uh, According to the independent variable, we can see what happened to other variable. right? This is we call that it is depend on the first quantity. So we call this quantity as the dependent variable, right? Then we want to see how one variable depends to another. The value of the independent variable is usually plotted along the horizontal axis of the graph. When we know about the two-dimensional axis x and y, right? We learned in our grade 11 or some things we studied about the graph, and we call the horizontal axis as x, right? Normally we take an horizontal axis as the x. So independent variable always usually plotted along the horizontal axis of the graph, right? Sometimes we take the product of P versus Q, right? Which means then we are in a plot of P versus Q, which means P is plotted on the vertical axis and Q on the horizontal axis, right? Normally, P is in the dependent variable, Q is the independent variable, P versus Q, right? P is the y-axis and Q is the x-axis. In plot, we can name as P versus Q. It means P is plotted on the vertical axis and Q is in the horizontal axis. Then what is the independent variable? Independent variable is Q and P is the dependent variable, right? When we using the graph, when we are drawing graph, important rules are here. We have to make large neat graph because we have to use at least half of the paper, right? Then we have to label the axis with the name of the quantities, graph and their units. Write a meaningful title, right? Then I will explain using one graph. Then these are the rules. After the explain this one, then label axis with the name of the quantities, graph and their units. We have to write down the what is the title, P versus Q graph, like this, right? And when the linear relation is expect use a ruler or straight line, straight edge to draw the best fit straight line. Right? Do not assume that the line must go through the origin. Make a measurement to find out if possible, right? Then we have to take the answer from using the graph. Then determine the slope of the best fit line by measuring the gradient, the graph, right? Delta y and over delta x. These are the variation of y divided by variation of x. Then we can find the slope of the graph or gradient of the graph, right? Slope of the graphs in physics have units since the quantities graph have units. Then you can see some experiment here. This is the introductory physics laboratory experiment. Here as an example, we can see here, then very small experiment, right? Then you can see in some string here, and in the first picture, it is in the equilibrium state in the first one. And the second picture, you can see some weight here, then and students are investigating how the length of a string varies with the weight hanging from it, right? Then we can uh, weight, we can increase weight, and according to this weight, we can investigate how the length of the string varies, right? This is the experiment, right? Varies weights, then we are varying weights, ranging we can take sometimes 6 Newton or something, can be hung from the spring. Then the length of the spring is measured with the meter sticks, right? You can see at the beginning of the experiment, this spring is in not a stretch one, it is in the equilibrium one. You can see 10 centimeter length, 10 centimeter mark, right? It is take as the L naught. Then after hanging the weight, then we can vary weight and hanging mass. We can vary hanging mass. Then according to this weight, according to this mass, according to this weight, then what happens? The spring length of a spring varies. Right? This is the experiment. Length of the spring is varying. And length of the spring is measured with a meter sticks. Right. I explained before, these are the important things in graph, right? This is very important when we are teaching students in school. We have to do the practical sessions, right? This is important that. You can see main thing is the graph title, the graph of displacement versus effective load, right? And the previous example, previous experiment, we have done increase the mass and measure the length of the spring. This is the experiment, right? The graph displacement X versus effective load M, right? This is the title. And important thing is need to name Y and X axis, right? Then X axis name as here and Y axis also name as, right? What is the Y axis is X displacement and X axis is effective load M. And you can see M here, right? Then the two drawing best fit line. Important thing is gravity point, right? What is the gravity point? Gravity point is the balance point of the graph. Balance point of the graph. Then how we find in the gravity point? You can see in the x-axis. Add all the x data. In here, x-axis is mass, right? Then you can add all the masses and divide by how many readings here, right? Then x1 to x8, I'm dividing by 8 readings here, right? And find the mean value of the x-axis. And same thing we can do for the y-axis, right? Take the summation of all data, 8 data, and divide by 8 and find the mean value of the y-axis. This is the best point, the balance point of the graph. We call this as the gravity point, right? Find the mean value of the y-axis. We name as x bar and y bar, right? Then you can see x bar and y bar. We mark this x bar y bar in our graph. Then others are experimental data point, right? We hang mass and measure the how many distance increasing of the spring, right? And again, we can increase in the mass. Then again, we measure how many distance increasing of the spring, right? Then we know this is the M is the independent variable. According to the mass, this extension, displacement of the spring is increasing. So we call X as the dependent variable. Then after that, we mark all the experimental points. Then we have to find what is the best fit line going through this data point, right? Then one tip can do, we are finding balance point of the graph. We call this as the gravity point. How we find the gravity point? In the x-axis, we can take the summation of the x point and divide by how many data point here. And also y bar can take addition of all the data in y-axis and divide by number of. This is the point, right? Then after that we can mark g x bar y bar. This is the balance point of the graph. Then we can find best fit line of the graph here. Now, gx bar y bar you can see. Then we can draw. We have to balance all the data points in the graph, and best fit line should be go to the gravity point, right? Sometimes graphs are into y equal mx scale. M represent the gradient of the graph, right? Sometimes the linear graph is y equal mx plus c. Here m is the gradient and c is the intercept of the graph, right? Then we can find the some things, some constant or thing using the slope of the graph or intercept of the graph, right? Then I think you have the idea how to draw the best fit line, best linear graph, finding gravity point. Then we can draw diagrams, go along, go through the gravity point. This is the best fit, right? Then can find the gradient. How we find the gradient? I told you before the changing data in the y-axis, divide by changing data in the x-axis, right? Then you can select 1, 2 points and uh, then find y dash and y double dash and y dash is the 2 points in y-axis, and according to the x points are x double dash and x dash, then gradient is equal data changing delta y divided by delta x. This is the gradient of the graph, right? In our previous examples, you can see sprint constant. We can find the sprint constant using our experiment. The goal is to see if the weight F and length L are related by F equal Kx. This is the Hooke's law, where X represent L minus L naught. Then L is increasing. L naught is the constant value. L naught is the length of the sprint when no weight is hanging from it. And K is called sprint constant. Then we can find sprint constant value using the graph, right? The given data here, the graph the following data in the table and calculate K for this sprint, right? Then you can see here F values and L value. We can draw diagrams. We can draw best fit line. Best fit line, then going through the G, X, Y bar, then you can find the best fit line. Then in the equation, you can see here some 2 points defined on the graph, right? 4.4 and 25 centimeter. Another one, 0.8 and 12 centimeter. These are the 2 points. Far away point is very good for the good result, right? You take the far away points. Delta L and delta F, you can find what is the variation of the x-axis and what is the variation of the y-axis, right? In the y-axis, delta L, and the x-axis delta F, right? Then we can find the slope of the graph, right? In the same graph here, what is the slope? Slope means y variation y divided by variation x. Delta L divided by delta F is the slope of the graph, right? Then F equal Kx represent the graph as the y equal mx plus c. Then we can find the K value using our graph, right? Then we can see all the important things are included in this diagram, this graph. Name, important. Sprint length versus hanging weight. Name of the graph, title of the graph. And see, x-axis, F Newton, independent variable. We are increasing weight. We are increasing applied force, right? According to the applied force, we measure what is the extension, what is the extension length, right? So length is the dependent variable. It is varying according to the F, right? L is the independent variable and F is the independent variable. The graph is represent y equal mx plus c, right? We can find the m. M means gradient or slope of the graph using the deviation of the y-axis divided by deviation of the x-axis. It is the slope of the graph. They can find the k value, right? In the graphical representation, most of the experiments are built in y equal mx or y equal mx plus c type, right? Linear graphs. Okay, then basic ideas of the physics finish. Now we can go to the mechanics. We can start the mechanics part. Before starting the mechanics part, you have to idea about scalars and vectors, right? I think you got the idea about the units, scientific notations, and graphical representations. I think you got the idea. Right. Now we will move to the next slide. Mm, I post one link in chat box. Then you can see. Please fill it, right? For recording of your attendance, right? And one student is logging in. Anjula, please fill this attendance link. Okay, I posted in chat box. Then I think you got the idea, right? Now we move to the vectors and scalars. Very important in physics, right? What is the scalar and what is the vectors? I think you know about this. Then we have to improve our knowledge of the vectors and scalars, right? These are the two type of quantities, scalars and vectors. These are the two different things, right? Scalar is a physical quantity that has only magnitude. Magnitude means size and can be represented by a number and a unit. Then scalars can be represented by number and a unit, right? Then example of scalars, then you can see here more examples: time, mass, temperature, density, and electric charge. And other thing is a vector. A vector is a physical quantity that has both magnitude and directions, right? Then vector is different with scalar because vector has direction. We cannot define vector without a direction. But in the scalar, only we need only number and a unit to describe it, right? The examples of vectors is velocity and force, right? Velocity has the direction and also the magnitude. And in the scalar has only number and we can represent a scalar by a number and a unit, right? And you can see in the vectors can denoted by A. Vector A can denote with a line with a arrow, top of the arrow. You can express the vectors, right? So sometimes then we have to add or subtractions vector, then vector additions. But we cannot do as the numerical numbers. As the scalar, we cannot add or subtraction vectors, right? It has to follow some rules. And you can see vector C of the vector sum of vector A and B. Then we call this method head to tail method. We can draw vector A, it is the arrow. In arrowhead, we call this as head, and other part we call as the tail, right? Then we draw our vector A in this line. Then this is the head of the vector A, right? Then A plus B. Vector A plus B means we have to draw vector B. How? From head to tail method. We call this as the head to tail method. Vector A head of the vector A, and you can see tail of the vector B, right? We start our vector B from the head of the vector A plus B, right? Then C is the resultant vector. C is the vector sum. The vector sum is represented by blue color arrow, head to tail method. Here the resultant vector, sum of the vector C can represent, we have to draw a line. You can see blue line here, blue arrow made head of the vector B. Right? Head of the vector B is made by vector C. C is represent A plus B. Right? Then also then B diagram you can see. In the B diagram also vector C can see B plus A. Then first we have to draw vector B. At the head from head of the vector B, we draw vector A, tail of the vector A and head of the vector A you can see here. Then vector C is represent B plus A. We can draw line with other arrow by joining C's head and A's head, right? A plus B we can represent like this. Then A and B are different figures. One is represent A plus B, other one is represent B plus A. But these two are not same, right? Then scalars we know 2 plus 3 equal 5 or 3 plus 2 equal 5. Same answer. But we cannot do these things in vectors because vectors define only numerical number and also the direction. Direction is important for the vectors, right? In two different type of summation you can see in figure A and B. Vector C is equal A plus B and B. Here B plus A. These are two different ones. Right? Then you understand that we have to draw vector A as the arrow. At the end of the arrow, head of the arrow, we are drawing tail of the vector B and head. Starting from tail of the vector B and draw head, right? Then C is equal A plus B. And also we can do vector subtractions. How? Then A minus B means A plus negative value of B. A plus minus B. Minus B means the direction is opposite to the vector B. In the first diagram, you can see B and vector A. Here we have to subtract A minus B. Subtract we have to add A and negative vector B. A plus minus B. Then minus B can draw. We can convert the direction of B. It is the minus B. Then we draw the diagram according to the head to tail method. Head to tail method. First A plus minus B. Then vector A you can see we draw here. And at the end of the head of the vector A, we have to fix tail of the vector B minus B. Tail of the vector minus B. Right? Then again represent A minus B by vector C. Right? Then minus B means, A minus B means we have to add negative value of the B. Direction is opposite. Figure you can see B in the one direction and minus B, it is opposite to the B direction, right? Then we can take A plus minus B. Okay. The graphical vector additions. We can see some diagrams in here. Explain A. You can see 200 Newton and 300 Newton in the same direction. The same direction, we can add this into the same direction is the resultant vector direction. Then we can add 200 and 300 equal to 500 Newton, same direction. But in the next one, we can see 400 Newton in the right hand side and 300 Newton in the left hand side, right? Then resultant vector, we can write it is situated to the bigger vector direction. And we can substitute 400 and 300, it is equal 100 Newton. The direction is take the more value is 400, larger value is 400. So 100 Newton direction is situated to parallel to 400 Newton direction. It is the big value, right? And last one you can see 250 Newton in the left hand side and also 250 Newton in the right hand side. So this is the opposite vectors. Values are same but in the direction is opposite. When we are going to add this A plus B, A minus B, then what happened? Summation is 0. 250 minus 250 because direction is opposite. Then sum is equal to 0, right? And also you can see F1 plus F2, we are following here. We need to follow head to tail method. First we draw the F1 and from the head of the F1 we can draw, you can see tip of the F1 and here we start in from tail of the F2. Tail of the F2 we can draw F2 vector, right? Then F1 plus F2 represented by this arrow, this blue color arrow, right? And this one, the direction is wrong. In the figure D, the last figure, it is direction is wrong. So this is not value. This is not correct value. This is wrong value. Direction is wrong, right? In the head of the F1, we have to draw tail of the F2, right? We call this as head to tail method, graphical representation of the vector additions. Another one is in the vector addition we can do using the component of vectors. Component of vectors we can do vector additions, right? Any vector can be expressed as the sum of the vectors parallel to x, y and z direction, right? Then component vectors indicate the magnitude and direction of the three vectors along the axis. And also the component has magnitude, units and algebraic sign. Then vector can be positive or vector can be negative, right? The sign of the component indicates that direction along the axis, right? We know that sign of the component. Then it means the minus sign, the direction is opposite, right? The process of finding the components of vector is called the resolving the vector into components, right? Then we can you do the vector additions using the component. Then you can see the right angle triangle here, 90 degrees and theta and phi. Then phi also will equal 90 minus theta because the sum of the angles of the triangle is equal 180 degrees in the right angle triangle. One angle is 90, so theta plus phi should be equal 90 degrees. Then phi is equal 90 minus theta. Then we can define sine theta according to the right angle triangle, right? In the sine theta, you can define sine opposite is B divided by C, right? And cos theta also we can divide. The adjacent side is A divided by C. Then tan theta also, then opposite side divided by adjacent side, B divided by A is the tan theta, right? All of you know how to define sine, cos and tan. Right. Then here you can see one diagram and also angle is mentioned at the 58. In the y-axis, length of the y-axis is Fy and length of the x-axis is Fx, right? Then we can define cos 58. How we define the cos 58? Fx divided by F, mod value. Mod value means not consider about the direction, only magnitude. Magnitude is Fx of magnitude Fx divided by F, right? And also sine 58. According to this triangle, we can define sine 58 Fy divided by F. And cos 58 can define Fx divided by F, right? Then you can see in this triangle, we can express value of the Fx as F cos 58. Is it clear? Then Fx is equal F cos 58. And in the sine 58 is equal Fy over F. Then Fy can define F sine 58. F sine 58, right? But in here you can see minus sign. Why minus sign here? Normally in the coordinate system, we take in x and y direction, and y is the up side is considered as the positive direction, and x right hand side considered as the positive direction. Here you can see Fy. Fy is situated to the negative side of the Cartesian coordinate system. Negative side. Then Fy is become as the minus sine, then minus F sine 58. We can use the cross multiplication here. F cos 58 equal Fx. F sine 58 equal Fy. But Fy is in the opposite direction. Normally we are taking positive direction as the upside direction. Here Fy is representing the down. Then minus sign become here, right? Then we can have Fy equal minus F sine 58. Okay. Then find in magnitude and directions, right? We can find the vectors, magnitude and direction from its components, right? Then Fx is equal Newton 5 and Fy is equal minus 8 because minus 8 is, you know, by minus 8 is situated the downside of the Cartesian system. The minus sign is come, right? Fx is equal 5 Newton. So then we can write theta value. Theta value is equal tan inverse Fy over Fx. Then it is equal 58 after dividing Fy and X value. But you can see mod value. Here we consider only value of the Fy and Fx, not direction. So theta is equal tan inverse Fy over Fx. Tan inverse opposite over adjacent. Then we can write theta as the 58 and also the resultant vector. Resultant vector is F, right? Resultant vector is F, but here you can see the right angle triangle. Then how we find this? This we can find using the Pythagoras theorem. Fx is squared plus Fy is squared, square root value. It is equal to the length of the F. Length of the F is represent the resultant vector. Resultant vector of F. Right? Then we can write Fx is squared and Fy is squared. We can find the resultant value and what is the direction with the horizontal. What is the angle made with the horizontal, right? Can find. This is the resultant vector of F. Then it is important we have to write the magnitude and also direction, right? Direction is represented by tan value, tan inverse value, right? And F represent with Pythagoras theorem, Fx is squared plus Fy is squared, square root value is equal F, right? Again, you can see vector components. I explained before what is the components and how to find the resultant vector. The summary of this one, again you can see vector Ax is situated along the x-axis. Now these are all are positive and vector Ay situated along the y-axis, right? We know the components. Now we are knowing the component. What is the Ax value and what is the Ay value, right? How to find the vector magnitude and its direction. Then vector A. Here, vector A represents the magnitude of the resultant vector, right? Then we can converted components. You can see Ax and Ay. Ax is parallel to x-axis and Ay is parallel to y-axis, right? It is situated in the right angle triangle. So, the magnitude can take Pythagorean theorem, right? How we find the A value? A is the value of the resultant vector. The vector A can be found, magnitude can be found, Ax is squared plus Ay squared, square root value, right? The Pythagorean theorem, in the right angle triangle, vector A can be found using the Pythagorean theorem. Ax is squared plus Ay is squared. But these are the vectors. So we need to explain about the direction. Important. The direction is important. So we can define the direction. How we define the direction? Angle between x-axis and vector. Right? Resultant vector is represent A. The direction can express angle between x-axis and the vector. How we find the angle? we can use the tan theta value. Then tan theta, also this is the right angle triangle. Tan theta is equal AY divided by AX. AY divided by AX. Then we can find the tan theta value and can express theta as tan inverse AY over AX. This is the direction of the resultant vector A. Right? I think you have the idea how we convert the vector component and also then given vector component and how we find the resultant vector. Important is Pythagorean theorem and also need to find the direction. Direction can express using the tan theta, tan inverse AY over AX, right? Right. Now this is one exercise. Before move to the exercise, now we have 3 students. So please make sure to enter your attendance using this link, right, in chat box. Right. We will see this example, how we do this one, right, using the vector components. Okay. Right. Then there is a force in 75 Newton. Angle is force on the ring. This is the rope. This is the ring. Resolve the 75 Newton force on the ring into horizontal and vertical components. Then how we convert our vector into 2 components. One with along the horizontal direction and other one is vertical direction. You can see one ring here and F equals 75 Newton is applied. How? Then angle is made with the horizontal direction is 48. Now, question is telling us find horizontal and vertical components of this force. Right? Try to do this one and you can see here. Then I am going to convert these 2 components along the x-axis and other one along the y-axis. Right? I will share my screen board. Can you see my whiteboard? I think you can see it, right? Is it visible? Okay. Then we have to resolve the 75 Newton force on the ring. You can see it. Need to convert into x and y components. Okay. And angle is 48 degrees. Alpha is 48 degrees, right? Can you see it? Then 78 degrees and F is 48 degrees angle and 75 F, right? Then we need to convert this in 2 components. Okay. You can see, we know we convert this in the x and y direction. One component along the x-axis, horizontal one, other one is perpendicular one along the y-axis, right? We should convert these 2 into x and y direction, right? Then here, force is acting this direction, downward. Then we can convert this here y-axis, another one is x-axis. 48 degrees. Right, then you can see, can draw the diagram and right angle triangle. Then we have to find the x value, this axis value. Right, this axis value. In the right angle triangle, we can define x, fx along the x-axis. Then we can see 75 degrees. See here, then 75 Newton acting on with the 48 degrees in the horizontal axis. Then we can convert this into x direction and also y direction. Right? X direction and also y direction. But positive side is x and y. You can see these are the positive side. Right? Along the x-axis, this is the positive side and positive direction, and positive direction is upside, right? But you can see when we are converting this 75 Newton in the x-axis, it is situated at the left hand side negative direction, and also we have to convert this one in the y-axis. It is also negative because downside. In down one, this is the positive one, other one is negative side, right? Then we can write fx. Fx is equal 75 cos 48, component of the along the x-axis, right? And fy is equal value, only value, 75 into sine 48. But minus sign is coming because standard one. Then we consider positive direction like this. So minus sign should become because the vector. Important thing is not only magnitude, right? But also then you need to explain direction of the vector value for the vectors, right? Then the important thing is direction and also value, right? Then you can see, then you can practice it. 75 Newton, we sweep the angle, sweep the given angle. Sweep the given angle to convert this in x direction. So cos theta. Then you can remember when we are sweeping the angle, then we can take the cos value of the angle. Here cos 48. But here no angle. Then we take sine part of the 48, right? Then this is the right angle triangle. Then we can find also then 90 degrees minus 48 is this angle 42, right? Also we can write here cos sine 48. Also we can write 75 cos 42. No, not wrong, right? This is also correct answer. When we are sweeping the angle, we take cos value. When we are sweeping the angle, we take the cos value, right? This is remember. You can remember using this method. Then 75 here, then we can convert along the x-axis. Here we sweep the angle 48, so cos 48. But no angle here, then oppositely sine 48, right? Minus sign is come because the direction is opposite to our standard path, right? I think you got the idea. Again, we will move to the next slide. Then also, again, I am posting the Google link. Please enter your attendance. Right. Then, shall we move to again our PowerPoint slides? Then here they may take the Fy in this question. Method 2 is you can see reference angle is 48 and find fx and fy. We can take the fy. Then here they consider fy is positive at the down, right? Down direction. Then here then we can write positive at the down direction is f this one also positive way, right? But in the standard method, we can write x and y same negative values, no problem, right? Here they mention that fx and fy taking as the fy the positive side, right? Then here you can see then first question we discuss about how to convert given force into horizontal and vertical components, right? How to convert given force into horizontal and vertical components. You can see, and then important thing is direction. Direction is important. Consider the direction. In this example, they consider F5 downside as the positive direction and Fx negative direction, right? But normally we are taking X and Y positive and negative directions in top side and the right hand side, right? Then in this example, I explain how to convert given vector into two components, horizontal and vertical components. Okay. Then other example is different than that, right? Then you can see the rectangular components of force are given as Fx minus value and Fy also minus value, right? Because the direction is opposite. Find the magnitude and direction of the force, right? Then here we have two components. These are perpendicular to each other. These are perpendicular to each other. Then have to find resultant vector, resultant force. Okay? Then the rectangular component of force are given Fx as minus 450 Newton and Fy as minus 300 Newton. Find the magnitude and direction of force. Try to do this one, okay? Then we will see it here. I will explain again this in board. You can start to find resultant one, right? X and Y are mentioned as the Cartesian coordinate system. Then Fx is negative, then opposite side of the 450 Newton. Another one, Fy, opposite side to the y-axis, Fy, this is equal minus 300 Newton. I put as the 300 Newton because I mark the direction like this. Then in this slide, we can see 400 Newton and 300 Newton, but direction are opposite. How to find the resultant value? I will explain using my board. Again, you can see. Right. I think you can see my board. Then Fx and Fy mention that the direction is given the opposite value to normal X and Y direction. So I mentioned direction is okay. So I can mention the value of the Fx and Fy as the positive signs, right? No need to put minus sign because I mentioned this in direction. The question is asking that is the resultant vector, right? Here, resultant vector. Then I think you remember I explained before. These are the perpendicular type components. Perpendicular type components. And we can find the resultant vectors using the Pythagoras theorem. I think you remember, right? Mod Fs equal Fx squared plus Fy squared square root value. I explained in theory part how to find the magnitude of the resultant vector. And also we can find direction. Can take the theta as with the theta made with the horizontal axis. Then tan theta can define how Fy divided by Fx. I explained before, right? Now you can apply this theory to find the resultant vector and also direction, right? We will see. This is the resultant vector. Capital F, right? Direction also here. Direction mentioned with theta angle made with the horizontal axis. Then now we can find how we know Fx value and Fy value. The resultant vector F value of the vector f, mod value of the vector f is equal, using the Pythagorean theorem, fx squared plus fy squared square root. Right? Resultant vector f, mod value. Value magnitude of the f is equal, what is the fx squared? 400 squared plus 300 squared square root value. Right? Then answer is coming as, what is the answer? 16,000 plus 9,000, 25,000, no? 500 Newton. Unit is important. In the physics calculation, unit is important. They can find 500 Newton is the mode value. Right? Then what is the direction? Tan theta. Tan theta can define here not 400, 450. Sorry. 450 plus 300. Not 400, 450 given value, right? The answer is 450 plus 300, then 540 point something is the answer, right? Then Fy, tan theta can write Fy over Fx. Then tan theta equal, what is the Fy? 450 Newton divided by 300. Can find the tan value. Theta is equal tan inverse 15 tan inverse 0.667 something, right? Then tan theta is equal 300 divided by 450. Sorry, right? 300 is the y-axis. Fy over fx is the tan theta. The tan theta equal 300 Newton divided by 450 Newton. You can take theta is equal tan inverse. Then you can use the calculator to find this 667. Then theta is equal, angle theta is equal 33.7. This is the direction. This is the direction of here. And tan theta is equal Fy over Fx. Fy is the 300 Newton divided by 450. Then theta is equal tan inverse 0.67 and take the value of inverse of the theta in 33.7. Then we can define F. Magnitude is this along the theta with the horizontal axis. 33.7 is the angle, right? Then this is the magnitude. This is the angle of the resultant vector, right? Then you have the idea. Then given fx and fy, how to find the magnitude of the resultant vector, right? And also you have to know how to find the components of the vectors, right? How to find the components of the vector should be now, right? Okay. We will move to the next one. Right. Again, I uh, share my PowerPoint. Then you can see here three vectors, F1, F2 and F3. The complicated question. Determine the resultant of the three forces using rectangular components, right? Then here at the point O, there are three forces acting on first one F1. F1 value is given as the 100, and other one F2 200 and F3 300, and given angles they define direction, right? F1 is made the angle 20 degrees with x-axis or horizontal axis, but F2 is making angle with y-axis 40 degrees, and F3 also making the angle in a negative side of the x-axis is 60 Newton, right? F3 is 300 Newton. Now, then what happened to point O? Point O then happening under three forces, acting three forces in O point. Then what happened O point? What is the resultant vector? Question is asking, determine the resultant of three forces. We have to use in the rectangular components, right? Here you have knowledge now how to convert the rectangular components, right? Theta here, how to find the fx and fy. Then, how to find the resultant. If they are giving two components in x and y direction, then how to find the resultant value, a value, right? Now, we calculate some vertical components. How then, as an example, we found horizontal and vertical components. How to convert uh, horizontal and vertical components. And next one we did, they given two components, rectangular components, and we found magnitude and direction. Now, this is the complicated questions. Then three forces acting here, and we have to find the resultant force, right? You can try. You can also try, right? In the point O, x and y axis they define. And also they define forces. F1 also acting with 20 degrees. And F2 is acting 40 degrees with F2 equal 200 Newton. We will see how to calculate it. You can also try it. Right. Here you can see the example in board, x and y direction mentioned, and also 20, 40 and 60, 100, 200 and 300. Right. How we find the resultant vector with components, right? Then we can convert this system into two components like this, fx, x direction, and fy. Right. Now first, we see how to convert these components to two perpendicular directions, right? Both are perpendicular. Then we know, if we know the fx and fy, we can find what is the resultant value, resultant magnitude and resultant directions, right? Acting on direction, right? Then we can convert, I'm taking all fx component in this direction. This is our positive direction, fx. Now we can write the components. First take the F1, right? And here F1 situated like this. Now we can convert F1, one component along the x-axis, other one along the y-axis, right? Now see the direction. I'm converting this. Then direction is, see the top of the pen. So direction is positive direction. It is along the fx axis. So I can replace f1 vector with two components, two perpendicular components, right? Along the x-axis, we can write f1 100 and you can see the angle 20. I told you if we shift the angle, we can take the cos value. Okay? If we shift the angle, we can take the cos value. Then F1 is shift the 20 degrees focusing x direction. So Fx is, we can write what is the component along the x-axis from F1. F1 cos 20. Any problem you can ask, right? It's not, is it, if it is not clear, please ask, right? Then F1 is pointing in the positive x direction, then 100. And I told you, shift the angle we can replace by cos 20, F1 cos 20, right? Then we write this component F1. It's okay. Now we can move second component. Second component F2, it is 200 Newton, but this angle is 40. If you want, you can find this angle. It's also 60, right? But if not, we can use, this is 60, here 15, 40, then 200 Newton. Consider 200 Newton. This is the direction of the F2. Now we can convert this into Fx and also Fy. Right? This is represent the direction of the F2 component. In F2, F in the Fx side, it is situated at this side, it's left hand side, but we consider right hand side as the positive direction. So this should be minus. This should be minus F2, but it is not sweep the 40 degrees. Now we can write 200 sine 40. Is it clear? And 200 sine 40, right? This is important. Minus sign coming here. We converting this our force into Fx and Fy. In the Fx direction is left hand side. This is the positive direction. So it is becoming as minus sign. Situated negative direction. And I told you, if angle is sweep, we can take the cos value. But this angle is not sweep the 40 degrees. So we can write sine 40 degrees. Okay. Now F2, x component is okay. Now remaining one is F3. Now see F3. Then we can convert F3 into x and y direction. In the top of the pen is represent positive direction, right? Direction, sorry, not positive, direction of the vector. And F3 is 300 Newton. I can convert this in along the x-axis and also along the y-axis. Along the x-axis, but it is situated to the negative direction, same as the F2, right? You can see F3 situated to the negative direction. So minus sign is come. Minus sign is come, right? Then F3, I'm converting F3 along the x-axis and along the y-axis. Then sign is negative and you can see F3 shift the angle. When we are taking the x component, F3 shift the angle 60. So we can write F3 cos 60. F3 cos 60. I think clear, right? Then we can convert one component Fx like this. Then now you can solve the Fx components along the x-axis, right? What is the F1? F1 is 100 and cos 20. You can find it, the calculator, right? What is the cos 20? Is it not clear? Please ask me. Find the cos 20. What is the value for cos 20? We can find using the calculator. Cos 20. This is the value. Error is coming, right? Please find the cos 20 value. I will write cos 20. That's right. And then other one, F2 is 200 into sine 40. Then you can find the sine 40 using your calculator. And minus F3. F3 is 300 Newton. Then we can substitute cos 60 as half. It's become as 150 Newton. Then we can find the value of Fx along the x-axis, right? Then cos 20 is 0.4 minus 0.7. 200 into 0.7 minus 150. Then we can find Fx value along the x-axis, right? 100 into 0.4, 40 minus 200 into 0.7, 140 minus 150. Then answer is minus 250. Direction is opposite. We are taking Fx along the positive right hand side, right? If I'm doing some wrong things, please tell me, right? Please give the attention to your uh, lecture. Then minus 250 along the Fx direction. Minus 250. Then we convert our force into one component, horizontal component. Now we can see the next one, next component along the y-axis, Fy. Fine. Now we try to convert components along the y direction. We convert this into two components perpendicular to each other to find the resultant vector, right? Now Fy. Then take F1 direction is upside direction is the positive value. Now take this top of the pen is represent the direction. Then F1 x component and y component. F1 direction is positive direction, right? Then it is positive. 100 into what's the angle? Then I told you, then in F1, see if the angle in x direction is 20. So we write cos 20. Then other one is F1 sine 20. F1 sine 20. Right. Now this is so. Now take the next one, F2. This is the direction. Represent the top of the pen. Then 200 newtons. If the angle is 40, if the angle is 40, then we can write 200 cos 40, the positive direction, plus F2 cos 40 degrees. And the last one, F3. F3 can convert. We converted it to x direction. It is if the angle cos 60. But here it is the down negative sign come. Top of the pen is represent the negative side. And F3, if the angle is not here, sin 60 minus F3 sin 60. Minus F3 sin 6. Then we can write F5. Positive direction is upside. F1 is 100 Newton into what is the sin 20. Then you can check it. What is the sin 20? Sin 20 is equal 0.9. We will take in one decimal, right? Then other one is F2, 200 Newton and cos 40. Minus 0.7. Please check, right? And F3 is 300 sin 60 half square root 3 by 2 minus 0.3. Please check again, right? Yes. Right, then we can substitute. Please check these values. When you are doing the questions, please check again. Then we can substitute for the Fy 90 plus 140 minus 990. It is equal 140. Please check again. Check the answer as the homework, right? Check answer. And then Fy is in the positive direction, 140 Newton. Now we converted our forces into the two components, perpendicular components. Now we can find the resultant one, right? Resultant vector. Now we know components Fx and Fy, but direction is opposite here. We can write Fy 140 Newton and Fx direction is opposite, 250 Newton. Now we can find the resultant vector. These are perpendicular to each other. Then theta can find, right? Then what is the F? Mod value is equal Fx squared plus Fy squared root value, right? Calculate this one, right? Fx is 250 Newton squared plus 140 Newton squared and square root. Again, we can find tan theta. Tan theta, we know Fy divided by Fx. Fy divided by fx, and theta is made the angle with left hand side of the x-axis, right? Not right hand side, left hand side of the x-axis, right? Then we can find fx over fy, 140 divided by 250. You can find the tan inverse value, right? If you want to find the angle with right hand side, what we can do? Theta is given, but we can write the angle with the positive x direction is this angle, alpha. Then if we know the angle theta, then we can find alpha is 180 minus theta. 180 minus theta is the angle with right hand side, right? In the positive x direction, we are asking what is the resultant angle with positive x direction, then we can find, then we know value of the theta, then you can subtract the theta by 180 degrees. Then can find alpha. Okay, is it clear? Now we know how to find the resultant vector by using the series of vectors. Here f1, f2, f3. Then first we converted to into components fx and fy. Then we find what is the resultant value and also tan theta. Right now, new thing is here. Then angle is coming the left hand side with but question is asking what is the direction with positive x direction. You can find alpha. How we find the alpha? 180 minus theta, right? These are the important things regarding the vector components. Right. Then we will move to the next point. Please mark your attendance also, and if any questions can ask, right? Okay, now we move to the next slides. Now we found the resultant vector of three forces. Next, the mechanics part. We can start the mechanics part. Then now we have to idea about the vectors and resultant vectors, scalars and things. Now we move to the mechanics, right? So first the motion in one-dimensional motion. Introduction to the kinematics. First we think the motion in one dimensions. Right. Important words we have to describe in mechanics: position, displacement, velocity, and acceleration. These are the very important when we study in the Newton's law or some. Newton's law's acceleration is very important, and also position and displacement, right? Then we can define position. And you can see origin and location of object here, x and y Cartesian coordinates. Position describes the location of an object relative to a reference point, relative to the origin, right? Then R is the position vector. R is the position vector is represented, right? Then these are two quantities you can see. One is direction and distance. And together constitute a vector quantity called the position of the object, and symbolic we can represent is R, and here R you can see one arrow because it represents the direction of the position, right? The position describes the location of an object relative to the some point, relative point or origin, right? Then these two quantities, direction and distance, you can see in this diagram. R is represent direction and also the magnitude, right? Then in the second figure, you can see RI and RF origin, right? Then delta represent here. Then this is the also displacement, right? From Ri to Rf, all are vector quantities. Then if a student is standing 3 meters to the right of the tree or something, we can say, as an example I'm telling you, then we say position is x equal plus 3 meter in the right hand side, right? But if a student is standing 2 meter left of this position, origin, left of the origin, we can say x is equal minus 2 meter. Okay, I think clear. Because the direction is important, right? From the origin, we measure the length in the right hand side, we can take the positive sign. But from the origin to left hand side, we take as the minus sign, minus position, right? To describe the location of something, we give its distance from the origin and the direction, right? Direction and distance important quantity called as the position. Then displacement. What is the displacement? Displacement is defined as the change of the position vector. You can see in this diagram, we are taking the reference point as the origin and the initial position vector represent Ri, initial Ri. Ri and vector Ri can see here arrow of the top of the Ri. So vector Ri here, right? Then final position vector can see Rf. Final position vector can see as the Rj, right? The displacement Ri and Rf we can take delta R. What is the meaning of delta? In mathematically, delta means that change in the quantity. Change in the quantity represents symbolic delta. So delta R is equal final position minus initial position, right? The displacement can be written as delta R is equal Rf minus R. Okay, clear. But we cannot subtract as the normal numbers. I told before is that at the beginning of the lesson, vectors, I told you we cannot add or subtract vectors as the normal numbers, numerical numbers. Here, represent by vector notation. Delta R, displacement of the object is delta R, can represent Rf minus Ri, vector subtraction, right? Vector subtraction and delta R can represent change in the quantity. Okay, then you have the idea about the position, displacement, what is the displacement things, right? Then other important thing is in the motion in one dimensional velocity and also instantaneous velocity. What is the velocity? The average velocity we represent by simple V of the particle is defined as the ratio of its displacement, change in displacement, delta x. Now you know how to find the delta. Delta x also say xf minus xi, right? Final position minus initial position. Xf minus xi divided by time interval delta t, right? This is the average velocity difference, right? Then other one, at the time, at the one point, we call this as instantaneous velocity. Instantaneous velocity. The instantaneous velocity v of a particle is defined as the limiting value of the ratio delta x and delta t as delta t approach zero. Approach zero means instant time, right? Instant time, not 1 second, right? Less than 1 second, right? Then ratio of the delta x over delta t as at approach zero, mathematically we can express as like this. Don't worry about this. Then we mention instantaneous velocity as limit delta t goes to zero. Means very small time interval, right? This is represent as limit delta t goes to zero in mathematics. Delta x by delta t We call this as instantaneous velocity. Right. We know about the displacement, average velocity and instantaneous velocity, right? At the one point, we can define velocity. It is the instantaneous velocity. And other one is, important one is average acceleration. Average acceleration. The average acceleration, simple A, of a particle is defined as the ratio of the change in velocity, delta V, to the time interval, delta T, right? Then we can define acceleration, delta V. Delta means changing, right? Mathematically, delta represents changing. Then A, acceleration is equal delta V by delta T, right? Delta V means final velocity minus initial velocity can divide by delta T, right? Again, we can define instantaneous acceleration as same as the instantaneous velocity. We can define instantaneous acceleration of the particle as the limiting value of the ratio delta V over delta T when delta T approach 0 at the 1 second, right? Delta T approach 0, we can define delta V by delta T as instantaneous acceleration. Mathematically, we can reference like this: delta T goes to 0, delta V by delta T, right? Okay, then you have idea, position, displacement, instantaneous velocity, acceleration, and average velocity and average acceleration, right? Then we can move to the graphical interpretations. I think you have idea about the break. Then you have idea. In the distance and time graph, we take then independent variable as time, x-axis as time, and y-axis represent distance. This is the distance versus time graph, right? The distance, we know distance is a scalar. But what is the difference between displacement and distance is displacement has magnitude and also has direction. But distance only, we can define distance only using magnitude. We can no need to define direction, right? The distance is the scale, right? Then distance and time graph, slope of the graph will give speed. What is the slope here? When y-axis represent distance, x-axis represent time, then what is the slope? By delta y divided by delta x. Delta y means change in distance divided by time interval. So, slope of the graph represent as speed. Okay. Then displacement time graph. Displacement is the vector quantity. So, we consider both magnitude and direction in the displacement, right? Then x-axis represent time and y-axis represent displacement. What's the slope of the graph? Slope of the graph means delta y divided by delta x, change in displacement divided by change in time, right? Delta y divided by delta t. So slope of the graph represent, we know what is the change displacement divided by time means velocity. Slope of the graph of the displacement time gives us velocity, right? And other one, velocity time graph. Velocity versus time graph. Then x-axis is time, independent variable. Then y-axis is velocity, right? The displacement is a vector quantity. So we consider both magnitude and direction. So velocity also vector quantity. We consider both magnitude and directions. Then the slope of the velocity time graph. Slope of the velocity time graph is represented acceleration, right? The area of the graph with x-axis will give the displacement. In the velocity time graph, we can take area under the graph as the displacement, right? We will see some graphical representation in the next slide, right? Here, graphical relationship between position and vector velocity. Then this is the time and position graph. In the previous slide, we explained time and the position. Displacement in the distance graph, slope of the graph gives us the speed, but displacement time graph gives us the velocity, right? Then you can see in time and position graph. Okay, then slope of the graph means we can take the time interval t1 to t3, then we can lay the tangent line at the point, right? Then slope of the tangent gives the instantaneous velocity at the point. At some point, we can draw the slope and can find the value of the slope, right? See, then here representing the displacement time graph velocity, right? And the finding displacement with constant velocity, then I told you from the velocity versus time graph, we can find total displacement area under the curve. Area under the curve, right? Then you can see in the graphical representation here, then this is representing constant velocity graphs, right? Why I am telling the constant velocity? Then at the t1 time, velocity also v1 and time is passing, then T2. At the T2, velocity also V1, right? The V1, then graph is represent constant velocity, right? Constant velocity. Then area under the curve, we can find the displacement of the object from T1 to T2. Okay? In displacement of the object from T1 to T2, we can find graphically area under the curve. This is representing rectangular shape. So we can find delta x. Delta x is the total displacement. Then V1 into T2 minus T1 or delta T, right? V1 into delta T, right? Delta x is represented here Vx into delta T for constant value, constant V1 value. We know the velocity is constant at the time T1, velocity V1, and also at the time T2, velocity V, right? Then area under this curve is represent the displacement, the object, right? And you can see some different curves here, but delta x is the area under the curve. But graph is represent velocity versus time graph, not the whole graph. Then velocity versus time graph, area under the curve representing what is the displacement within this time interval, right? What is the displacement within this time interval, T2, 1 to T2, right? I think you have the idea how we find the displacement using the graph, right? With the constant graph, you can see this is area under the curve means area of the rectangle, right? And also these are the variable velocities, but all theory is same. The area under the curve is represent displacement, total displacement of the object, right? Okay, then graphical representation of the kinematic is okay. Please ask question if you have. Right. Then other one is very important things. I think you are familiar with these kinematic equations for motion along a line with constant acceleration, right? We consider here acceleration is constant. Acceleration is constant along the straight line with constant acceleration. We can find initial velocity, final velocity, acceleration, time, and displacement, right? We can see some relationships between position, velocity, acceleration, and time. Okay, the kinematic equations we introduce next are relationship between position, velocity, acceleration, and time that apply when something moves with constant acceleration. Okay. Then you can see two essential relationship between position, velocity, and acceleration enable us to find the position of an object moving along the line with constant acceleration. right? Then delta Vx. Delta Vx we can define how V final velocity minus V initial velocity. This is the change in velocity. It is equal Ax. Ax is constant during the entire time interval. X is representing acceleration along the one dimensional, no, then we represent Ax along the x-axis, right? Ax is constant during the entire time interval, then delta Vx equal Ax into delta t, right? Then other equation can take delta x equal half Vfx plus Vi delta d. If Ax is constant during the entire time interval, then we can substitute these things to this equation and we can rearrange. Then we can find some equation for the kinematic equation, relationship between position, velocity and things, right? Then you can see linear motions. We can apply this kinematic equation. Delta x is representing distance, displacement or distance between initial and final position. Sometimes we put this as S, right? Then we can write this as the S also, right? Another one, V squared. V is representing final velocity and V naught is the initial velocity and A is the acceleration and T is time. These are the kinematic equation. I will write in both these equations. Okay. Right. Consider my screen. I will explain again kinematic equations. How in any symbols we can use V naught or V or U, initial velocity and final velocity. Here you can remember if I write equations in easy remember for you, right? Then object is moving along the straight line with acceleration. A. I am putting two arrows representing the acceleration. And initially, at the beginning, we will take time as 0 and at the final time is simple t, right? And initial velocity I am taking as u. If you want, you can take v naught or vi or something, right? V naught at the after time t, final velocity I am taking as v. If you want, you can take it as vf or v, right? And under this motion, at the initial to beginning, total displacement I am taking as s. If you want, you can take delta x, right? This is way to easy remember, right? Then u is initial velocity. And v is final velocity. T time. And a acceleration, constant acceleration, right? We build the kinematic equation under constant acceleration. And S is the total displacement. Total displacement, right? Then we can write the kinematic equation, set of equation. S equal ut plus half at squared. And v squared equal u squared plus 2as. Right? Another one, v equal u plus at. You can take easily remember this, right? V initial velocity, u initial, v final, time t, acceleration, and total displacement. These are the kinematic equation with the constant acceleration. S equal ut plus half at squared, v squared equal u squared plus 2s, and v equal u plus at. Right? Then we can apply this equation according to our questions. Right? Again, I share PowerPoint slides. Right? And you can see screen with three kinematic equation, then delta x representing s, right? Right, please, right. We will see some questions. Then some rules are for using linear motion equations, right? Rules for using linear motion equation. Here, we all assume that acceleration is constant. Under constant acceleration, the motion is high. We use vector quantities, not scalar quantities. We always use instantaneous velocity. Instantaneous at the beginning. What is the velocity? Not average velocity, right? Direction of vector is indicated by sign. Incorrect use of signs will result in incorrect answers. Then we consider some direction as the positive direction. The velocity is happening to the opposite. We should put the minus sign, right? If not, the incorrect answers can come, right? In the next slide, then problem solving steps. Then you can follow this step to solve your problem. What is? Draw a quick sketch. Then they are given some data and something. So you can draw some sketch, right? Then identify given in the problem and write them down. Then what is the given data? What is the initial velocity, final velocity, acceleration? Then you can write down, right? Then determine what is being asked for and write down with question mark. If they are asking about the displacement, put S and put question, right? Then you can understand. Select an equation that uses the variables known and unknown you are dealing with and nothing else, right? Then you can understand what is the known data, what is the unknown data, then what I have to find, right? Then so it is easy. Then sketch is important and identify the given thing and determine what is the determination one, put the question mark and select an appropriate equations to it, right? Then fill in the known values and we can solve the equation, right? These steps can follow. Right, okay. You can see one questions and draw the diagram, draw the sketch and write down the things and what is the appropriate equation we can use. Right. Go quickly. Draw the line. A penguin slides down a glacier starting from rest. Starting from rest. That means initial velocity is 0. U. I'm taking U as initial velocity. Penguin slides down the glacier starting from rest. Means U is equal 0. And acceleration at a rate of 7.6 ms minus 2. This moving with acceleration 7.6 ms minus 2. Right? And if it reaches the bottom of the hill, right? Bottom of the hill is 15 ms minus 2. We can draw line, straight line as the description. Then V is given 15 ms minus 1. Final velocity is given. How long does it take to get the bottom? Question is asking what is the time interval. How long does it take to get the bottom? Question is asking what is the T. T equals 0 to T equal T. Then you can mark the line as I did in this here. When initial velocity is given 0 and final velocity is 15 ms minus 1 and T equal T and A is equal 7.6 ms minus 2. Then we know about the U 0 and know about the V 15 ms minus 1 and what is the acceleration 7.6 into ms minus 2. Now find t. Unknown value is t. What is the equation we can use here? What is the equation we can use? U, V, A and T. I'm taking V equal U plus AT. V equal U plus AT. Right? V is 15 and U is 0 and A also, then direction is, this is the positive direction, right? They are not mentioned about the negative values. Then U is equal 0 plus A is 7.6 into T. Then can find T. 15 divided by 7.6 second. This is the answer. Then you can calculate, right? Very easy questions in the kinematic equations. In the next one, a car slows from, this is important, slows from 45 ms minus 1 to 30 ms minus 1 over 6.2 second. How far does it travel in that time? Car slows down means there is an deceleration, right? Deceleration can happen because the initial velocity is greater than to final velocity. If they are in happening acceleration, final velocity should be greater than initial velocity. So here less value and mention that slows, right? Then how far does it travel in that time? Then you can say, draw the line and mark all the things we know and what can find relationship between them and can find, right? The car slows down means then happening here, we can put minus a sign, but not given about the idea of acceleration. And starting velocity, u is given as 45 ms minus 1, and final velocity, v is given as 30 ms minus 1, and time is 6.2 second, and asking question how far, what is the distance, right? Right? Then minus a we can put 6.2. Question is asking about S. What is the equation we can use? We know U, 45. We know T, 6.2. And V, 30. And A, don't know. And S, have to find. Then we can use two equations. And two simultaneous equation can use, right? Then time is given, then I am putting equation V equal U plus AT. You can put, right? What is the V? 30. What is the U? 45. But minus sign because slow down. If you want, you can put plus A into 6.2. Then automatically A is coming as the minus, right? Then 15 divided by 6.2, but minus A is deceleration. But the acceleration is deceleration, right? Now we know about the A, then have to find the V. So you can put V squared equal to V squared plus 2AS, right? V squared is 30. Or we can put another equation. S equal ut plus half at squared. Also you can put, right? It is easy. And this one, right? We know about the A and U, P, then can find X. X is unknown value. And you can put S equal ut plus half at squared equation to find the how far does it travel. Okay? Then also another questions. Then try to do a cyclist speed up from his 8.5 ms minus 1 pace. Then as he accelerates, he goes 325 meter in 30 seconds. What is his final velocity? But not mentioned about the acceleration. The given data, what are the given data? U and S and T as same as the previous one. Then we have to find the acceleration. Then we can find final velocity B, right? You can follow these questions as the previous one and take the simultaneous equations and can substitute A value to one equation. Okay. Right. Then at the other part is in the kinematic equations, we can take free falling objects. We can have this is the one straight line motion, one dimensional motion, one dimensional motion under the gravity, free falling objects, right? In the same equations, the kinematic equations, we can apply for the free falling object, but acceleration is equal to gravitational acceleration. You will see. Okay. Then I'm asking, what happens when you drop a stone? Then you can see in diagram. Then what happened when you drop a stone, right? Then what happened? The stone falls down with increasing velocity due to gravity, right? Here are we consider no any air resistance. On Earth, free fall is an idealization since there is always some air resistance, but in the free falling, we consider no forces act on object other than the gravitational force that makes the object falls, right? Then what happened when we drop a stone? We know the stone falls down with increasing velocity, right? And if you put the heavy object fall and it is thus heavy object fall faster than the light object. Hmm? No, if we not ignore air resistance, the all objects fall with some acceleration g, right? With same acceleration g, all objects fall with same acceleration. So heavy object or light object are not heavy object is not faster than the light object if we not considering air resistance, right? Under the gravity, there are motions happening, right? Then what force acts when object falls? We know gravitational force, gravity acts on falling object. Can you hear me? Hello?
Yes, miss.
Yes. Okay. Right. Right. Then free fall acceleration, then object is free fall. Acceleration due to gravity. A. Acceleration is equal gravitational acceleration vector G, sometimes called the free fall acceleration, right? Then G is taking as 9.8, or we can take this as a 10 for our easy calculations. Then motions of an object when only gravity acts on it, right? Then air resistance ignored and acceleration is constant, direction is downward, right? Acceleration due to gravity under the acceleration of gravity. So we can take equations, kinematic equation for free falling object, but acceleration can replace by g, and downward positive is downward positive, right? G direction for g is downward, consider as the positive. Then we can replace our kinematic equation by g. Then v equal u plus gt, and s equal ut plus half gt squared, and v squared equal u squared plus 2gs. We can replace a by g, right? Then other thing is, then important is, then if question, so something mentioned dropped object, dropped object, and sometimes it can be mentioned thrown downward, thrown downward. Then what is the difference between these two? Then question can come like this, right? In moving object in under the gravity, free falling object can take dropped object. Drop means this is released from rest. Released from rest. Okay. Then it means the initial velocity u equals 0. Then other one, thrown. Thrown downwards or something. Thrown. Object is throwing. We take downward or upward thrown objects, right? Then what happened? It is not released as rest. Here, u not equals 0. There is some value for the initial velocity thrown objects, right? Where the difference u not equal 0 in the thrown downward. Okay. Again, we will go back to slides. Right. Here you can see some graphical representation, right? Acceleration, we consider downward acceleration is positive value, right? Then the diagram is showing free falling object, right? Under, now this is the throwing object in upward. Throwing object in upward represent this diagram. Velocity versus time graph for throwing object in upward, right? Acceleration at the highest point, then we know we're taking moving up part, you can see here. Then acceleration taking as the positive direction in downwards, right? Acceleration at highest point, if an object is thrown straight up, its velocity is 0 at the highest point of its flight. We know when we are thrown object in straight up, then what happens? Then velocity is decreased. Velocity is decreasing, and at the highest point, velocity becomes as 0, right? Velocity becomes as 0. Then velocity is decreasing because acceleration due to gravity acts downwards, right? If we throwing object in straight up, the deceleration is acting on that object, so velocity is decreasing from some value to 0. Then after that, what happened? At the highest point, velocity is equal 0, but gravitational acceleration is happening to downwards. Then again, at the highest point, the object is again starts to move. Start to move in down, right? 0 to an increasing velocity. Okay. This graph is represent that motion, right? And you can see at the beginning, at the time 0, there is some velocity. there is some velocity. On the way up, the y component of its velocity, Vy, is positive. The positive y-axis is pointing up. On the way down, Vy is negative. Then you can see the acceleration is due to gravity is in the downward. So velocity is going decreasing, and at the time here the velocity becomes as 0, right? Then Vy is greater than moving up because the value is positive. The direction is opposite, means the acceleration is acting on downward. So velocity is decreasing and becomes at the 0. Again, what happened? Just acts as the free-falling object and Vy change continuously. It must pass through 0 to change the sign. At the highest point, the velocity is 0, but the acceleration is not 0. Then again go down, right? Then Vy less than 0 here, move it down. Slope is taken as the minus g because the consider upward point is the positive direction here, right? Upward is positive direction, but acting slope is minus g, same as the moving up and moving down. Same acceleration happening, the gravitational acceleration. The chart is showing like this for the object is thrown straight up, right? But velocity is coming 0 because acceleration is happening downwards, right? Deceleration can happen. You should remember, at the highest point, the velocity is 0. At the highest point, velocity is 0 of this motion. Right. You can see one question here. A ball is dropped and hits the ground with the velocity at this rate 25 ms minus 1. How far has it traveled when it reached the ground? This is the free falling object question, right? Free falling object question. We are dropping object. I told you drop object means initial velocity is equal 0. U is equal 0. But and hits the ground with the velocity 25. Then what is it? V. Final velocity is 25 ms minus 1. And we know acceleration due to gravity. Acceleration is equal g 9.80. Then we can use, right? Then how far has it covered? Question is asking what is the distance? What's the total distance ball traveled when it reached the ground, right? Okay, we will see then 25, no? Down. Initial velocity is u equals 0, and at the finally, if the ground is 25 ms minus 1, and acceleration due to gravity is happening downwards, right? Positive direction. Then question is asking how far does it travel? What is the S? Right? Then we know about u, v, a, g. If you want, you can take 10 ms minus 1, 2 I am taking. And S is don't know. What is the equation we can use? Relationship between V, U, A and S. Right? I'm taking V squared equal to squared plus 2AS in downwards. Right? All are down. Then V squared is 25 squared. V squared is 2 into 10 into S. Right? Equal S. We can find value of S using the kinematic equation, right? Very easy. Then other important thing I explained before, when we are throwing object in upward, initial velocity is u, but acceleration due to gravity is happening downwards. I'm taking here positive direction is the motion direction, but G is happening downwards, right? G is happening downwards. Then what is happening here? At the highest point, U is equal 0. And again come back to the down. In the same straight line, come back to the down, but velocity is increasing due to G, right? You must remember that at the highest point, velocity is 0. Right? If you want, we can find highest position h, right? Then can use at the highest position, velocity is 0. Okay. Okay, we can move to the next part. Kinematic equation can apply projectile motion, right? We will see the next one, projectile motion. Motion of projectiles. Now we consider objects, we call as the projectiles, in free fall that have non-zero horizontal velocity component. This is part is as the parabolic part we can see. Important thing is, just as in the free falling object that have a non-zero horizontal velocity component. In the straight line motion, straight line free falling object, there is no any horizontal velocity component, right? Velocity is changing along the up and down, then in straight line, in the vertical direction only. But we consider projectile motion, important thing is there is a horizontal velocity component. The motion of the projectile takes place in a vertical plane. The angle of elevation is the angle of the initial velocity above the horizon. Once the projectile is in air, the only force acting on its downward gravitational force, provided that the air resistance has a negligible effect the motion. Right? Then here, there is a horizontal velocity component. But thing is, the horizontal component is not changing. Right? We can take two components. Then we know how we take in the component of the vectors. Then here, they given some velocity with the angle. Then there are two velocity components. One is horizontal one, other one is vertical one. We know at the vertical part is acting as the free falling object. So acceleration due to gravity is acting on the vertical component as the free falling object, right? Then what happened? Then velocity can change in the vertical component. Vertical component velocity can change due to the acceleration gravity, right? But in the horizontal velocity component, there is no any acceleration. There is no any, we consider air resistance as ignoring here, then no any acceleration along the horizontal direction. So horizontal velocity component is constant throughout of the motion, right? It is the important thing is projectile motion. Okay. Then you can see what is the projectile. Any object is projected by some means and continues to move due to its own inertia. Then we can see this is the parabolic part. Then one is throwing object but you can see not it's in the straight line. We can see some angle between the horizontal and the direction of motion, right? Then this is the parabolic bar in the projectile motion. Then here, the motion of projectiles, I told you in the horizontal component. Then you can see here. Then we throwing object with theta angle with horizontal. Then dark red color angle is represent the initial motion of the object, right? Theta angle. So we know about the vector component. We know how to take the vector components. Then here theta angle we can take two components. We can convert this component into two types. One is along the horizontal direction. Then here mentioned as Vix because along the x-axis initial velocity mentioned as Vix, right? Then we can take other component along the y direction as Viy. I mentioned here Iy, then initial velocity y direction. I think you can understand, right? Vix represent initial velocity in x direction and Viy represent initial velocity along the y direction, right? We can convert these. One is V cos theta and other one as V sin theta, right? Then consider about the y component. Then you can see y component Viy, it is changing due to the gravity, right? It is changing due to the gravity because then there is only y component, then what happened? It is decreasing. You can see the size of the arrow. I mentioned it is decreasing. You can see size of the arrow and moving. And what happened? At the highest position, Vy component goes to 0 due to the gravity, due to the deceleration. Y component is equal to 0 at the highest position. Okay. Then again you can see this is at acceleration due to gravity and change in the direction of the velocity. And talking about vertical component only, Vy component only, then Vi component at the highest position is goes to 0. Then again converting direction, then you can see size of the arrow is increasing. Uy, Vy, and at the final position it represents V final Y, Vf, right? Can you understand? Vyf. Then in this projectile motion, vertical component is changing as the free falling object. Then see, right, horizontal component. What is the horizontal component? Vix. But there is no any force. There is no any acceleration acting along the horizontal direction, along the x direction. So we know there is no any acceleration, there is no any deceleration. What can we say about the velocity? Velocity is not changing. Velocity is constant. Along the horizontal direction, velocity is constant. Then you can see same size of arrows can see in the horizontal direction and also Vix is the initial velocity. Same velocity can see throughout of the projectile motion. Vix. Changing part is Vfy. Okay. Then you should understand about Vi part at the maximum height. At the maximum height, Vy part goes to 0, but in the horizontal component, the velocity along the x-axis is constant, right? Okay. Then here you can see graphene projectile motion sometimes, vertical position and vertical axis is going like this as the free falling object. It is changing, decreasing velocity at the middle sign, then at the highest position, velocity is equal 0, vertical velocity only, right? And the other part, you can see negative sign because direction is opposite. But in the horizontal position, right? In the x is increasing, but we can see no any change in horizontal velocity component. Horizontal velocity component is in the same mm, same value, right? It is not changing. You can see in these diagrams. Okay. Before moving to the right, in the problem here, you can see in this diagram some words I have to introduce you. Path is curved, and what some questions they are mentioned as maximum height and horizontal distance and horizontal range, right? I will explain before what are these words. Then next we can move to the question. The velocity component, these are the important things in the projectile motions, right? Motion of an object projected into air under gravity we call as the projectile motion, right? Then here two motions at the same time. One is horizontal motion. Horizontal motion happening with constant velocity. And other one is vertical motion. In the vertical motion, just has the free falling object under gravity. Under gravity, right? In the horizontal motion, we can say A is equal 0, no any acceleration. And B also constant, but in the vertical motion, A is equal G, acceleration due to gravity, velocity changes, right? If we throw an object at angle theta, if we throw the object with angle theta, right? Velocity u, then we can take two components. Horizontal direction. In the x direction, we know, you know how to take the component u cos theta. This is fifth angle, then we can write u cos theta. And other one can replace u sine theta in the vertical component, right? This is affected by gravity. Is affected by gravity, but u cos theta, this one is no change. No change, right? Then path is parabolic path. These are the things under the projectile motion, right? Then this is the parabolic path in the projectile motion. Here are some words. Can take maximum height. H, maximum height. Then we can define it the highest vertical position reached by the particle at the vertical velocity is 0, acceleration is g, right? At the highest point. Maximum height. Capital H. Question will ask what is the maximum height, like this, right? The maximum height, vertical velocity at that point is 0. Here Vy equal 0, but Vx is same. Right? Then other word is range. R. Other one is range. Or vertical displacement, right? horizontal displacement range R. The horizontal distance traveled by the project before it hits the ground, right? The horizontal distance traveled by the object. Traveled by the object is horizontal uh, distance, so represented by R range, right? It is measured along the horizontal axis direction and it is depends on the velocity and angle at initial. There is no any effectiveness by the gravity theta and u. It is depend on theta and u, right? Other word is time of flight or flying time. Time of flight, flying time, right? What is the flying time? The total time the projectile stay in air. At the beginning, t equals 0, and after t equals t. This is can call the time of flight or flying time, right? The total time the projectile stays in air, this depends on the vertical component of velocity. It is varying with vertical velocity, right? These are the words maximum height, range, and the flying time. The questions can ask what is the range, what is the maximum flying time, like this, right? We will see our problem. Okay, you can try this question. During the cricket game, a batsman hits the ball at an angle for 40 degrees with the ground at the velocity 20 ms minus 1 as shown below, right? Then show that the initial vertical component of ball value is given. Then calculate the time it takes the ball to reach its maximum height. And calculate the horizontal distance traveled by the ball before it hits the ground. Angle is 40 and 20 ms minus 1 initial velocity, right? How we find initial vertical component of the velocity and the time it takes the ball reach the maximum. Another one is R. Correct. With the question, angle is 40, 20 ms minus 1, and T asking question T and T, right? First, we can take horizontal component of velocity. We can convert this into the two components. Question also asking about the vertical component, right? Ux and Uy. Right? Then we know how to take the component of velocity. This is the direction and 20 is shift the angle 40, then Ux is equal 20 cos 40. Another one is 20 sine 40. Then what is the value? We can find. The question also asking about the vertical component of the velocity. cos 40. Point 6, no? You can check it. And we can take ux and uy. Just check the value of the cos 40. Right. Then how we find the t value? Then answer can take as ux and uy. Then you can calculate it. Then how we take the maximum, the time interval to reach the maximum? In this position, what we know? T have to find. At the maximum point, what is the value for Vy? Then Ux is same. It is not changing. What is the value for U1? Is equal 0. Maximum point Uy is equal 0. Right? And we can use this one. Then we, at the maximum point, at the maximum height, at the maximum height, we know V is equal 0. Right? 0 to T path. And U is equal Uy 20 sine 40. You can find the value, right? I will explain the theory part. U is equal Uy 20 sine 40. Right? And question is asking time interval T. What equation we can use? We know A is equal acceleration due to gravity, the G. The downwards. These are in upward. This is happening in downwards. Then what is the equation we can use? I am taking in the upside V is equal U plus AT. Right? I can put the equation V equal U plus AT from initial to maximum height point. Maximum point of the motion I can take time t can find. And u is 0, v is 0 and u is equal uy. Please find this value. Find the value, right? Then uy minus, because g is acting downwards, we can put minus gt. I'm taking g as 10 ms minus 2. In your paper, they will mention what is the gravity. If they took the mention as the 9.10, you should take the 9.8, right? The paper mention is 10, you should take the 10, right? Then I'm taking G as the 10, ms minus 2. Then we can put value and T is equal Uy divided by 10. It's clear? Then what? This is the time interval. It is in the upward, then maximum height. At the maximum height, time interval is given uy, right? Sine 40 is 0.74. 0.74. Twenty. 14.8. check the answer, right? Then divide by 10 means 1.48 second. We can take this as 1.5 second, right? Time is 1.5 second. Time to the higher maximum point. Okay. Then what is the next question is asking what is the R, no? What is the R? Range. So here, when this is the time is 2 times, but we can take the equation. I will explain from the equation. Then in the total time, then if you want to find the total time, then this is equal T is equal to T. This is okay. But then if we want to find the flying time, capital T, then if you have to find the flying time, then what can we say? Then you can see here in the vertical displacement in 0 to A, in 0 to OBA path. In the vertical direction, what is the displacement? Total displacement in vertical direction. What is it? Now, we considering vertical one, the ball is going up at the maximum point. I'm considering on the vertical part, right? Going up at the maximum point, again going down to the ground. What is the total displacement? Vertical displacement throughout this motion. Is it have some value? Displacement. Displacement means initial, final position minus initial position. But the position is same, right? Consider the vertical part. Object is moving at the maximum height and again come back to the ground state. Then what is the total displacement in OBA plan? Displacement should be equal 0. S is equal 0. Okay. Then I'm going to find the flying time. Capital T. Capital T. The total displacement in upward, it is equal 0. Right? Now, S is equal 0. I'm applying the equation throughout the motion. Then T is equal capital T. And what is the S? S is equal 20 cos 4. U. Initial velocity is equal 20 cos 40. So it's 20 sin 4. 20 sin 40 is the horizontal component. Vertical one is 20 cos 40. In the throughout this motion, we know S is equal 0 in the vertical displacement. And this is happening under gravity. A is equal G, but it's in downwards, right? Then how we find the T? We know U, S, T, and have to find the T, and A is equal G, right? This is equal 14.8, no? Okay. Then how we find the total displacement can find and take applying the equation S is equal UT plus half AT for the total motion OBA considering vertical motion, right? Then S is equals to 0, but U is 14.8 into capital T minus sine half 10 capital T. Okay. Then this is cancelled out 5. Then 0 sine here, we can cancel 1t Then 5t is equal 14.8. Then t is equal divide by 5, right? 6. So this is 2 times as the previous one, right? Then we find the total time. Then this with this total time period, what is the displacement through the horizontal direction? What is the displacement through the horizontal direction is t. At the same time, you should understand vertical displacement is 0, but in the horizontal displacement is r for the t, time interval t. Now we have to find the r. So it is very easy. Now we find the t in the horizontal direction. In the horizontal direction, have to find the total displacement. R, S. What is the S? Should be equal R. We have to find. And flying time t is equal to 2.96. Right? Then what is the U? Initial velocity of the position is 20 cos 40. Ux 20 cos 40. Now question is asking t, but any acceleration along the horizontal direction, no any acceleration. A is 0. It is moving with constant velocity. Throughout the motion, we know the horizontal component of the velocity is equal constant value. This is not changing 20 cos 4. So we can put the equation of motion, have to find the R is equal ut plus half at squared, but half at squared passes no on the constant velocity. Until constant velocity, displacement can find velocity into time. Is equal ut, velocity into time. We can find velocity into time, then displacement is r and 20 cos 40. What is the value? Please check these answers, right? I don't know the math calculation is right or wrong. Please check answers. Cos 40 into 20. 13 point something. 4.96. Then you can please check. Right? It's equal ut. Then R can find. This is the range of motion or horizontal displacement. Right? These are the things under the projectile motion. You should remember about the two components of the velocity, right? Vertical component and also horizontal component. Horizontal component is not changing. Flying time is same at the flying time. Total displacement along the vertical direction is equal 0, but in the horizontal direction it's equal r. At the same time, there are two motions in two dimensional motions along the x and y direction, right? Okay. The projectile motion also finished, right? And now time is 4. Next day, then not we have to start then other part. Today time is not enough. Next day we will discuss other things, right? Okay. If there you have any questions, so is it clear the session? Kalsuni?
Yes, Miss.
Okay.
Clear.
Okay, please update your attendance, right? In the chat box.
I updated, Miss.
Okay. Okay, thank you. Right. We will meet next day, okay? Then at the 4th week, I think you have quiz, right? Right. Then we will see the next day, okay? See you.
Okay,
Bye.
Miss. See you. Bye.
Bye.
Thank you, Miss.
Okay.